Hey guys, and welcome to Functional Print Friday, and welcome back to my shop. So this week I want to take a look. The heck happened to my coffee? Aw, come on. So in case you missed it, about a month ago I got a false copyright claim on a couple of videos from BMG Music here on the channel. And it's actually for the outro music. They matched the outro music that I use in pretty much all my videos. I'm surprised they only matched two of the videos. But I put a dispute in on them because the song that they were claiming I'm using, yeah, I'm not. It's a completely different song. And I actually went into that in pretty great detail 3 or 4 videos ago. I'll link it down in the description of this video if you want to check it out. But I do have an update. So just yesterday, which was actually the Thanksgiving holiday here in the United States, I got this email from YouTube that you guys have up on your screen right now, letting me know that BMG Music failed to review the dispute that I made against their copyright claim within the required 30 days. And this is great news. We have won this round. I say this round because BMG Music could just choose to reopen the claim. Unfortunately, I don't believe there's any limit on the number of times that they can just keep making the same copyright claim against a video. I don't think they'll do that. My original theory was that once I disputed it, they would wait the full 30 days and then just deny my dispute. And the reason companies do that and why that's so common on YouTube is because it allows them to just capture 30 days worth of revenue for that video. All of the ads that play, they get the revenue on that instead of their revenue going to the creator. So it's pretty common practice on YouTube. I'm hoping that since they didn't deny the dispute, that maybe it went into a queue for a human to review and the bot didn't have a high enough certainty to actually bother having someone review it. I don't really know, I'm guessing, but all I know is they've let the dispute on both of the videos that they claimed copyright on pass, which means I should be getting that revenue back, which is nice. One of the videos that they claimed it on probably didn't make more than a few dollars, but the other one's actually the second most popular video on the channel, so it probably did make some revenue. And it'd be nice to actually get that. So I just wanted to give you guys an update on that. For now, at least, it is very good news. And thank you all so much for your support. There were so many wonderful comments on that video, and actually many of you reached out to me directly as well to ask if there is anything you could do, and several of you have reached out since just, to kind of see how it's going and how I'm doing. And that's the update. As of yesterday, nothing but good news. All right, let's talk about what I want to actually work on this week. So here on the bench this is the test TPU Bellows that we made here on the channel a while back. And I made this after coming up with the idea of printing a TPU Bellows flat. And the way this is done is they're all removed now, but between each of the pleats here in the bellows on both this side and this side was just a thin piece of dissimilar material, either PLA or PETG, between the layers of TPU. And so it prints flat, prints a little bit more expanded than this because you have those additional layers in there. And then once it's done printing, you can kind of pull this all apart, get all those layers out, and you're left with this really nice bellows structure. So halfway around the world in Italy, someone saw that video and reached out and asked if I could potentially design and make them a custom bellows for what I think is a piece of optical equipment. I'm not really sure. Let's go up to the computer and I'll show you the pictures that I have, and we'll talk about what we're going to try and do today. Here is a photograph of the piece of equipment that this bellows is going to be used on. And we need to design the bellows to sit up against this flat face here in the photograph. And I actually have no idea what this piece of equipment is. I'm assuming that it is something optical, just based on sort of the appearance of it and the fact that we've got this other rail back here that looks to be adjustable, but I don't know for sure. All I know is that we need to design the bellows to sit up against this flat face. There's 7 millimeters of width to work with here, but I think we actually need to stay within 6.5 millimeters. And fortunately, we don't have to draw it just based on rough dimensions and this photograph, because the person that requested this actually also supplied this photograph and a drawing to go along with it. I believe this is also printed in TPU, although I'm not sure. This was an attempt to make this sort of printed in its expanded state. The problem is, to print this, you end up with pretty wide layers of TPU, and this guy is just not going to compress very well. And I'm guessing, I didn't ask, but I don't think this compressed down to the 10 millimeters of total height that was required for this. The good news is, like I said, I actually have the drawing that created this. And we do have a flat face you can't quite see it in this picture, but I do have a flat face that we can essentially steal to start this design from. So let's head over into OnShape and I'll show you that. All right, and here we are over in OnShape. And as I mentioned, a drawing was supplied for this, and that's actually what you're seeing on the screen since it was supplied in step format. So I started by just importing that step file into OnShape, and one end of this just sort of ends in a point. I don't know if this was the top or the bottom of the structure, but the other side has a nice flat face already. So the first thing I did is actually just steal the geometry of that face to base this sketch on. So this is, I call this footprint. This is essentially the footprint, this face out here of the overall Bellows structure. Next thing I did is design the Bellows sketch or structure of the sketch itself. There we go. So the gray section is the TPU, and the white section, at least the white sections between the gray sections, will be our support material. So this guy is going to print as one solid stack, and then we'll expand it open and pull the support material out. So this guy is then able to open up as a normal Bellows structure. And I can unhide my part here. All I did was just take that sketch and then wrap it around the other sketch of the footprint. And probably easier here if I just go into section view. See, we'll hide our sketch. So that makes it a little bit easier to see what is going on. It's surprisingly tricky to sketch. It's not that difficult of a geometry to look at it like this, expanded out, or in a section view like this, but it is actually a little bit tricky to sketch. And I did make it easier by putting in variables for like my pleat width, the width of the connections at the end, just to make it easier while sketching. And I have some ideas of how to potentially make this even easier as we make adjustments to this, but baby steps. I wanted to get this done, get this printing, and just see how it goes, because this is a lot narrower, like the width of these pleats, than the previous tests I've done with this method. So, all right, I'm gonna export this out as a step file, get this sliced up, and I'll bring you guys back. All right, we're over here in Bamboo Studio. I've got this imported in, and I'm not going to spend a lot of time talking about the settings because I went into all this stuff in much more depth in the video where I originally came up with the idea for printing the Bellows structure like this. But the key settings are to make sure that you have your style set to snug, and that you set both the support and the interface to whatever material is going to be your interface material. Oftentimes you'll just set the interface to be the other material and leave your support material to be the same as whatever material you're printing from. In this case, you want to make sure that both your supports and the interface is the dissimilar material that is not going to stick to the TPU. I used to set all these manually in here. The slicer has gotten much smarter. Since the original video I did, all you need to do is actually just make these two selections, and it'll ask you if you want to set all this stuff to the settings that are best for using a dissimilar material for supports. That all happens automatically now. The only other change I made in here was setting the interface pattern to concentric. And if I slice this up, you'll see why. What that's going to allow us to do is on concentric, it's going to have one filament path or one line width path all the way around until it makes the full width. That's going to make this a lot easier to remove, hopefully, at least in comparison to hard corner edges. Now, there's something a little bit weird going on in the slicer here. So if you notice, I have the pattern set to concentric for the regular process as well. So if we go over to, if it's in quality or strength, yeah, it's in strength. Top surface pattern, bottom surface pattern, internal solid infill pattern. I have these all set to concentric, yet one of the layers, so see this one here? That is not concentric. Now, if we go up another layer, it then layers a concentric path on top of that. So that's not actually what I wanted. But here's the thing. Since that's our TPU layer, I think we're actually going to get a lot more strength that way, assuming it doesn't have a hard time making all these short lines. Because if we did this as concentric, the second layer would stack directly on top of this. And it should work fine, but it probably wouldn't be quite as strong as actually having, I mean, I guess we end up with the same exact path here, but for our section up here and down here, they're going to run the other way now. So that actually should give us more strength. The supports, it does both layers as concentric. So I'm not sure why the difference there. If you know, let me know down in the comments, but I don't think that's going to interfere with actually being able to print this. So, all right, I'm going to slice this up. I'm going to print it. I'll bring you guys back. All right, our first test print is complete. And I've been messing with this off camera for a while, trying to get these layers separated. They do take quite a while. I've got probably 20 minutes into this, actually just sitting at my desk. And unfortunately, I tore it at the back. I think if the whole thing was just circular, we might get away with just that single edge connection. I think we're going to have to go up to, like 2 nozzle widths of connection, because as we get into these transitions, I think that's where it tore, is right at the corner here. Now, there was quite a bit of mess to this from the travel moves that crossed this, and it's possible that my TPU filament is not completely dry. I'm going to dry it again just to make sure. But I think this is still a good first test print. I think we learned a lot. Let's actually measure the width. Still over 10. I mean, I could probably cheat and push. Yeah, I mean, I could push on this and get it down under 10, but the reality is that's over 10. So we've got a little bit of work to do there as well. I think we could probably reduce the size or reduce the thickness of the end pieces. But we're also going to lose, we're going to lose a little bit in doubling the connection at the ends too, because that's going to reduce the, so if we think about each one of these pleats, the longer these are, the more this guy expands. So we're going to be reducing the length of each one by a little bit by doubling the width of the connection. Got to think about that. I also discovered, while trying to get this one to separate, I tried a little IPA thinking it might loosen these up, and it did seem to help. So I probably made as much progress in the last 5 minutes as I did in the first 15 minutes once I started kind of squirting a little bit of IPA into the layers. So that might help us in the future. The other thing I'm noticing here is, and I don't know if the camera's picking it up or not, but I can see facets all along the edge of this. Each facet is maybe, I don't know, about 10 millimeters or a little bit shorter in length. I can't remember if I exported this as a 3MF or a step. I'll have to check. We shouldn't be getting those. If I'm exporting this as a step and we're interpreting it in the slicer at a high enough resolution with arc fitting on, we shouldn't see any facets at all. That should look perfectly circular. So let's take a look at that as well. All right, we got some work to do on this. I have an idea for the drawing that might make revisioning this a little bit easier. So let me go mess around with that a bit. I'll bring you guys back. All right, we are back in OnShape, and I'm excited to share this with you guys because even though this probably looks like pretty much the same body structure of a Bellows that you guys saw in V1, the actual body of the Bellows is now built from a sweep of a completely different drawing. Rather than sketching manually the structure of the Bellows like I did originally, I've made that sketch fully parametric now, and this will actually automatically generate and regenerate based on that parametric sketch. So let's go into a section view. I'll show you what I mean. Let's grab one of these faces here, and we'll pull this back to where we have a nice view of the cross section of this guy. And I'm going to bring up my variables table, and we'll keep this in view so you can see what's going on. So the one change that we needed to make, and potentially the only change that we needed to make, was the actual connection at the end. That is the width of the point where the two pleats connect to each other. And before it was 0.42. It was one line width with a 0.4 nozzle. So that's what our original one was based on. And you can see how thin that connection is. And I think, it's probably enough if these pleats or the support material between the pleats was easier to get out, but we really need the additional thickness there to make this guy hold together better. So I updated that connection to be 0.84, which is now 2 line widths. And you can see now that thickens up. Now that also means that we lose a little bit of that width. And again, we don't have a lot of real estate for that width. That is our big constraint here, but we need that. We really need the 2 line widths to strengthen up that connection at the end. And I think my original Bellows test, same thing. That was done with 2 line widths for the connection point at the end. Now notice I have over here in my variables table sections. Let me set this to 1. So this is essentially now the smallest that this can be. It's 2 end plates and 1 section. And the section is made up of 2 pleats. So you see it starts over here, runs this way, comes back, and then comes back to the same point. By designing it that way, and then I'm going to show you how I did that in the sketch, but just for the sake of seeing the cross section here, now as I add additional sections, it just keeps multiplying that sketch of those sections and then throws on our end thickness to both sides. And to further differentiate the ends here from the center section, let's make the ends like 3. There we go. Now you can really see what's going on here. And if we go 10, 15, we can make this guy however many sections we want. And if we want to change the size of the pleats, like right now they're 0.32, so this is going to be printed at 0.16 millimeter layer heights. So 0.32 is going to be 2 layers. So there'll be 2 layers of support material, 2 layers of TPU, 2 layers, alternating back and forth. Let's say we wanted these pleats to be a lot thicker, and we wanted these to be 1 millimeter. There you go. Everything just automatically regenerates. And for that sake, I mean, a regular bellows that we would design for something else where we had a lot more width to work with. Let's say we had, width we probably can't go too high because the sweep still has to work on the tightest angles of the drawing that we're sweeping around. So I don't actually know if we can go any bigger. Let's see. Oh, okay, we got up to 10. At some point, I think this is probably going to break. Yeah, can't go to 15. 12? Ooh, 10 might be the widest we can go. That's an artificial constraint. Again, that's a constraint just based on our drawing, and probably not these curves here. It's probably this tight curve down here on the bottom, if I had to guess. But I can hear you down in the comments. How big can we make it? I don't know. Let's try 100 sections. Ooh, it's thinking. Still thinking. There's a lot of math to do. I know how I built the formulas in the drawing, and I don't think there's necessarily a simpler way to do it, but it is fairly, oh, there we go. It is fairly complex, the amount of math that it has to do to generate this. But we go all the way to the end, you can see it is still slapped on the end point in the right place. And we could go narrower with this too. You can see as long as it works within the shape that we're sweeping around, it should be able to edit this. And now we're still sitting at 100 sections. So yeah, it's got a lot of math to do, but there we go. It did it. It's just generating that whole body automatically based on whatever we're inputting here. So how did I do this? All right, let's take a look at the sketch. All right, I set us down to 4 sections here in the sketch just to make everything sit a little bit easier in the screen. And if I set this at 1, you can really see what's going on here. Again, we have our end connection, and then we have a single section in here. And you can really see how these mate together looking at it like this. So here's our origin point. So we have a flat bottom on the section, and then it wraps around, comes back, and then has the riser that comes up that then mates against the next section. So if we put this to 2, you can see those mate together nicely. And the distance of the end section, well, on the bottom, it's actually just away from our origin point, so really no extra math to do there. We just throw in the variable names. But there's a construction line here that calculates the starting point of the end connection on this side. And that's just taking all of the different thicknesses that are stacked up there and multiplying that by the number of sections. And that is, I think that is this one here. Yeah, there we go. You can see pleat thickness times 4 times the number of sections. Now, the way that this is duplicating those sections is done with a linear pattern. And you can see the variables that make up the linear pattern in here as well. So this long arc here is the angle for the linear pattern. And let's just change this. I think that's probably the easiest way to explain it. Let's make it like 30 degrees. And we'll go 3 sections. So that is the angle at which it's duplicating that linear pattern. And actually by doing that, you can now clearly see the construction lines that set our distance for that end connection. So we'll set this back to 90. And the other thing that is happening in here for that linear pattern is, where is it? There it is, number of sections. So that's saying 3x, that matches here. That is actually a variable in here. If I expand that open, and I've got 2 other variables over here that are calculated to sort of help plan the size that this bellows is going to end up being. So notice estimated height compressed and estimated height expanded. And these are really just kind of rough guesses. You'll notice I'm coming in here, I'm assuming a 4% loss or not really a 4% loss, but 4% of extra stack up for height compressed, because it's a little complicated to guess how much this is going to end up compressing down to. It's not just the height of this printed out, because think about it, this is going to act as a hinge, this is going to act as a hinge, this is going to act as a hinge, so that the tip of this can come down and sit against this, the tip of this can come down and sit against this, but that's not going to happen perfectly. There's a little bit of texture on both sides, and that's what that 4% over here in this multiplier is doing. And then this just multiplies out by the number of sections. So again, it's kind of a guess. I think we were at, what was this? I think we're at 9 sections with a pleat thickness of, I want to say 0.32, and our end thickness was like it was 0.6 something. It's called 0.65. Yeah, you can see now we're getting down close to 10 millimeters. And this was sitting roughly at almost exactly 10 millimeters when I had before I went and started tweaking these dimensions here while I'm explaining it to you guys. We also get the estimated height expanded. That is just kind of taking a guess at how far this guy is going to stretch out. And the key thing to tweak in here is right here. So we're assuming that we're going to get 42% expansion on these sections. So we get 42% of the usable width of each one of the length of these pleats. In a perfect world, it would stretch out to almost 100%. We're not going to get, it's not like these corners or these hinges are going to straighten out to be perfectly straight. But if we stretched on it hard enough, we could essentially make this, let's call it 0.99. Just edit the formula in there. You can see this guy would expand out to, again, in a perfect world, 255 millimeters almost. So I know there's a lot going on in here. Hopefully this makes sense to you guys. I'm really curious to hear down in the comments if you would have done this in any different way. I could think of a couple other different ways to do it, including a pattern of the body geometry that we create as well. But what I couldn't wrap my head around, if I did it that way, was how I would position the ends. By doing the linear pattern in the sketch, I can still make sure that the ends, which are a different thickness, land in exactly the right place, regardless of how many sections or other tweaks I make to the math here for the bellows. All right, enough talking about this. Let's get this all sliced up, printed out, and see how we did. So I'd like to start a new tradition here on the channel this time of year. I've noticed when we get to about this time of year, we're about like a month from Christmas, that a lot of channels will share like gift ideas, things that are on sale, stuff like that. And I'm not really into doing stuff like that, but I do like my toys, tools. And I thought, well, what if I went back through my Amazon shopping history for the course of the last 1 year, so stuff that has to be in 2025, and shared with you guys the things that I've picked up new in 2025 that I think are absolutely awesome, that I would immediately just purchase again if they went missing. And these are all things, by the way, that I have paid full price for. They're things that I selected, paid full price for. There's nothing here I'm going to share with you guys that was sent to the channel or that someone's paying me money to show you guys. This is all just cool stuff that I picked up over the course of the last year that I wish I knew about before. So we'll start with this guy right here. This is from Knipex. I think that's how it's pronounced. I've heard different people pronounce it different ways. It's a fairly small pair of pliers. I'm not actually sure if they make more than one size. I'll put links to the exact items that I'm showing you guys down in the description of this video. I'll title it like 2025 Rich's favorite things or something like that. But what's cool about these pliers is if you look at the jaws on these, they have teeth going in both directions. So you can grab things like screw heads or stuff that's just otherwise really hard to grab with a normal pair of pliers. And Knipex, like the material that they forge this out of and then harden it, like it really, the teeth on them really hold up. I've used these several times and I can't even see any wear marks on them. Now, these aren't heavily used. Again, I just got them this year. And these are adjustable. You can push a little button here and they slide over so you can work with, larger items as well. It's still a fairly small pair of pliers, so you're not going to grab something huge, but I got them primarily for like screw heads that are stripped out or just really small things that I'm trying to get a hold of that normal pliers will slip on, and they're awesome for that. All right, the next thing is these Wago connectors, and these two in particular are not actually new to me this year. I have these up here just so I can show you why I want to show you those guys down here. Now, if you're not familiar with these Wago connectors, these do the same thing that wire nuts do, except they're way nicer. So this one holds 2 wires, and you open these up, Put your wires in there, either solid or stranded, and then close this, and you have a nice firm connection on those wires without worrying about them slipping out, or especially like if you have, I don't actually use the ones that are just two that much. I'll use a regular wire nut because regular wire nuts are cheaper. I do still use these sometimes in special instances, especially if I'm joining solid wire to stranded wire. This one I use all the time because if you've ever done electrical work and tried to join like 3+ wires, and even if you twist them ahead of time with pliers like you're supposed to and put the wire nut on, it's really hard to still get a nice tight connection with a whole bunch of wires at once. And up until at least fairly recently, this is the biggest they made. So if you wanted to connect more than 5 wires together, you'd use multiple ones of these and then have like a pigtail running between them, which was pretty inconvenient. Well, I'm not sure actually when they started offering it. I didn't see it until this year. They've now got a 10 space one, so you can join up to 10 wires in one block with just one piece, which is much more efficient and saves a little bit on space as well. I haven't even used one of these yet. I like these so much that when I saw the 10 space, I just ordered a box right away. The other thing I noticed that they had new, again, maybe not new this year, but new to me, this and this actually do the exact same thing. But this style is much more convenient if you're trying to do like a butt joint of 2 wires. This one you have, both of the wires are entering on this side, so you end up with both the wires exiting from this side. Well, that's not always convenient. Sometimes it's nice to have, like to join a wire, sort of in the middle of a bundle or whatever, where one wire is coming in this side and the other wire is going out that side. So again, just 2 new additions that at some point in time Wago started offering that at least I only noticed this year. This next one is a specialized wire stripper for just the outer jacket of a multi-conductor cable. So this is just an old PC power cable. I've got tons of these. I'll often save them because you have a nice plug end, to plug into the outlet, and then you can just strip this back and wire it into whatever you're working on. Well, historically, I have always taken like a razor knife and either tried to slit this down the length without going too deep and hitting those wires, or taking a set of cutters and just sort of nipping in at the end and sort of trying to cut that jacket all the way back a little bit at a time for as far back as I want to go, and then trim it, back at depth. Well, recently I discovered these guys, and this particular one is made by Wycon Tools out of Germany, and this is spring-loaded, this part here, and that is like a little knife there that rotates around, and you can adjust how far that sticks out with this little red wheel back here. And now if I want to take off just this outer jacket, all I got to do is just pull this, or actually push this with my thumb, let it spring back, and then I just rotate it on our wire. And after running it around a few times, oh, it could go in the wrong direction. Let's try that again. Yeah, it feels like it's doing something. There we go. Look at that. And there's still a little bit to break through. I've noticed if you set it far enough where it completely cuts this, because think about it, the 3 wires in there, it sort of forms a triangle. So you still have points where these wires stick out closer to the edge there. If you set it to go deep, actually that's an even better way to see that, what's going on in there. So if you set it to the depth where it's going to cut all the way through, you're probably going to nick the wires, but you only need to really just score it. Let's do it again. Am I going the wrong way again? We'll just go both ways. So if you look at that, now if I just give this a little bit of a bend, where it wasn't quite cut all the way through, it's scored enough, I can just bend this guy back and forth and slide that right off, and you have a nice clean cut there. If you're doing a bunch of wiring with this multi-conductor cable, this makes it so much faster. Again, link in the description. The next item is just this plain old little squeeze bottle. And at this point, I think I've bought 5 or 6 of these. I think they're sold in 2 packs, if I recall. I've got ones out here in the shop with IPA, kerosene, and gas. And even the gas one, it doesn't seem to evaporate out. I think because you've realistically only got this tiny little hole here at the top, but they're really nice for solvents. I have another one for just IPA down near the 3D printers, because it's super nice. Like if I have a TPU print and I'm trying to get it off the bed, just squeeze the bottle. There's a tube that comes all the way down to the bottom, so unless this is completely empty, at pretty much any angle, you just give it a little squeeze and some squirts out. Super nice to have around the house for all sorts of things. Again, this is one of those things I can't believe I made it to this point in life without having a bunch of these. All right, this next thing is just these little wipes. And these are, I don't know how to describe them. If you've ever used like a paper lens cleaning cloth, I think it's the same thing. But these are sold in, I think, 4 packs of these boxes at 286. And what's great about these is, and it's weird, they don't describe them necessarily as this anywhere on the box, but they don't seem to leave lint on anything. I now use these, well, I use them for lens cleaning. Actually, I use them to wipe my glasses off. They work incredibly well for that. But I have another box of these down, again, by my 3D printers because they're great for cleaning off your carbon rods or your steel rods, as well as your lead screws on 3D printers, because they don't leave anything. They don't leave, like if you use paper towels, you get like little white fuzzies or little pieces of like white dust. These don't do that. They work really, really well for wiping your linear rods or anything that you're trying to wipe off and not leave like lint. All right, this next one is the set of hex drivers that I picked up and then made this TPU case for. These hex drivers are awesome. I find myself pretty much using these every time this range covers the size that I need. This particular set goes from 0.7 up to 3, which is, just to give you an idea there, 0.7 is really, really tiny. Like, unless you're watching this on like a 100-inch screen, you probably can't even see the actual hex shape at the end of that. And then 3 is, it's still decent size. I mean, this covers pretty much all the fasteners that you typically have on a 3D printer or, you know, other small electronics. But the Wera ones are really, really nice. The end, it like pivots, so that rotates, and then this funky looking shape here is actually meant to be grabbed between your thumb and forefinger. And then this seats back against your palm and it pivots, so you can push and twist at the same time. They're really, really nice. All right, next thing is this little guy right here. This is a calibration board for multimeters. Over the years, I've collected many different multimeters, and how do you know they're accurate? This is actually one I just purchased used this year off of Facebook Marketplace, and I compared it to some of my other meters, but how do I know they're accurate? And you could send these out to have them calibrated, but it's expensive, like a decent amount of coin, and you're paying shipping both ways. This calibration board was, I think it was less than 20 bucks. And yeah, I mean, I'm trusting that it's accurate, but it looks like this was calibrated with an HP 3458A, and they show the exact values that they recorded for the different ranges. So the way this works, oh, and if you buy this, this is all you get. It's just this board. You've either got to get one of whatever batteries fits there, or it's got a USB power connector down here, so add a cable and an extra brick. I just power it that way. And it doesn't do anything at first other than just light up, but if you push the green button, it will switch into one of the ranges. And if I put it into the multi-tester here, I just put the leads in here. Now it's outputting 5 volts, or actually it's outputting exactly 5.00133 volts. So we're pretty darn close here. It's slightly off. That should actually be 5. No, actually that would be right because it's rounding. So yeah, that's correct. So 7.5 is actually 7.49156. Yep, we're right on there. You guys get the idea. I'm not going to click through each one of these, but if you've got a pile of multimeters in your collection and you want to know if they're actually right, or you want to calibrate them yourselves, this is awesome. All right, this next one is probably my favorite new toy of 2025. Did I say toy? I meant tool, of course. And I've used this a couple times on the channel, so many of you guys have seen this before. But this is a borescope. And I owned several borescopes before this one. And they were always the cheap variety, like the Wi-Fi ones that you connect to an app on your phone. And they're just about worthless. I mean, I guess it's better than nothing, but the video feed is always washed out. Nothing's ever in focus. This one has a nice high-def screen on it that's built right in. But check this out. I think it's long press on that to boot. Yep. So this actually has autofocus. So whether you're right up on something or far away, you notice it's blurry for a second and then it autofocuses and adjusts. Everything is always in focus regardless of what the distance away is. And the other trick that this one has up its sleeve is, like I said, you can actually control the end with this wheel here. So say you're in, you know, like you're in a pipe or something And what you want to look at is not where the camera is pointing. You can actually control the end of it with this wheel here and get around and like look around corners, stuff like that. It's awesome. Again, I guess it's kind of a toy as much as it is a tool, but definitely one of my favorite new things for 2025. Do I have to even say it? Link in the description. All right, and our next test print is done and came out much cleaner than the first one. I have not done any cleanup on this at all. This is exactly how it came off the bed. This is probably about 1/3 the amount of sort of stringy bits that are hanging on versus the first one. Now, I mentioned when I took that first one apart, I used some IPA in a squirt bottle just to saturate some of these layers, and it did help separate it a bit. So I'm wondering, what if we take alcohol and just put this guy in a Ziploc bag with some alcohol? Suppose we run the risk of it potentially compromising some of the bonds of the TPU as well until it dries, but I want to try it. I mean, worst case scenario, we can reprint this, but on the upside, I mean, this might make this guy more or less just like fall apart. So let's try it. This is going to take quite a bit of IPA, but if it works, we should be able to reuse it. Pretty sure what these bags are made of is not going to get eaten up by the IPA. Guess it's going to be a pretty big mess here on the bench if I'm wrong about that. I think it's leaking a little bit there at the edge. All right, well, I think that's sealed up well enough. I'm going to give this about 5 minutes. I'll bring you guys back. All right, it's been a little over 5 minutes. I'm probably going to regret doing this. I think this IPA is probably going to really dry my hands out now that this guy is soaked. But if I put gloves on, I don't think I'm going to be able to get a good grip on it. So let's try this. Boy, that still feels really stuck together. I wonder if leaving it in there longer would be beneficial. I was kind of hoping this was going to separate a lot easier. All right, this is still really hard to separate. I know once I get it started, it's going to be a little bit easier, but I'm going to be fighting with each layer. So I'm going to try putting it back in the IPA for longer. Again, if we leave it in there for a really long time, we might compromise the bond of the TPU to itself, but what do we have to lose? I'm going to put some more IPA in here as well. I'd like to see the whole thing submerged. All right, we should be able to get this IPA back. All right, I'm going to set a timer for, I'll leave it set for 1 hour. All right, it has been 1 hour. Let's see if that has made any difference. Well, if it's made a difference, it hasn't made a significant one. See if I can get one of these started. All right, well, unfortunately, this is not going as easy as I hoped. It will get easier as I get more of this separated. It just makes it kind of easier to hold on to it. And you get a little bit more leverage the more of it you get separated. But yeah, the IPA didn't really help us that much. So this is tough for me to do. I'm kind of holding it off at an angle here because you guys are right in front of the workbench and a tripod. So I think I'm going to work on this off camera. I'll bring you guys back. All right, guys, it's actually the next day. I spent quite a while with this guy after turning the camera off last night before calling it quits. And you can see I've still got little pieces of PETG in various places on here. And I tore this somewhere, I think in one of these corners. I can't remember exactly where. This is the one that we had 2 line widths of connections between the pleats. And I kind of made the assumption that it was probably indestructible, given those 2 line widths. Well, it wasn't. If you pull hard enough, it'll still tear. I think it's torn on like the last pleat in one of these corners. Can't remember exactly where. I stopped messing with it because I remembered when we did the test of this, way back when I came up with this process, I remembered that different brands of TPU seem to like different release materials better. So this one was done with PETG. I thought, you know what? Let's try one with PLA instead. See if that makes a difference. All right, it finished. And you can see it doesn't look very good here, but this is actually pretty normal. This is the same amount of stringing that I had on the other ones as well. I think it's not retracting this material because it's support material, but it didn't seem to interfere with the last ones. So I also brought up my better scraper. This is the best one that I found that's still sold new today, and it does feel very similar, but this antique one that I have, it still seems a little bit thinner at the end. It's better at getting into these. So I'm gonna get the camera off over to the side. Well, actually, let's just try and see if I can separate this at all first. Ooh, maybe. I could feel that starting to give a little bit. Let me get you guys over here out of the way. All right, well, that time lapse that you guys just saw was 34 minutes long. That is how long it took me to post-process this guy. These are really difficult to do because the width of the pleats is so narrow. The larger one, the test one that I did, let me grab that. Yeah, this one was a lot easier because the pleats are really wide. So you can kind of flex it and bend it, and you have a lot more leverage to pop those guys out. Because the pleats are so narrow on this one, really quite a bit of work to get them out of there. Now, through the magic of YouTube, it is actually the next day, and I have finished another one. And this one took me a little bit less, probably 20, 25 minutes. And this one also came out perfect as well. So 2 of these were requested. 2 of them are done. I guess let's double check the dimensions. This should compress down to 10, but let's just check it. Yeah, wow, that guy is like right there, right at 10.02. I could probably squeeze it and go, yeah, I mean, if I squeeze it, I can go less, but where I would comfortably take a measure with the calipers, it's basically right at 10. And this needs to open to 50, so let's set these at 50. I'm quite sure it's gonna open further than that. Make sure I'm grabbing in the right spot here. I don't wanna miss any pleats. Oh yeah, I mean, we could probably get almost double that, but that's okay because to 50 requires very little effort. We're not stretching these out that far. So yeah, that'll work. Well guys, that ended up being a lot harder than I thought it was gonna be. Again, mostly down to just how narrow these pleats are, but lesson learned. And at least all that sketch work that I did for this, including all those formulas and the variable table, can now be reused. I mean, I drew this originally in SketchUp. This was done in OnShape. I can essentially just take that, even though these are so different, the exact same sketch would reproduce this. And the point is, I can essentially draw the outline of whatever I want and then take that sketch and essentially apply it to pretty much any shape and adjust the width, the connection at the end, thickness of the end plates, everything. In fact, I could probably even do some additional customization for the end plates to maybe even include like a pattern of screw holes or all sorts of stuff. So we'll probably see that again in a future video. Guys, as always, thanks for taking the time to hang out in the shop with me for this week's video. It's always really nice to have you guys out here with me. And special thanks to the patrons that support this channel on Patreon. I could not do this without you guys. Thank you so much. If you want to check out the Patreon, there's a link down in the description of the video. And patrons also get access to my OnShape source design files. So for example, this week that sketch that I did with the formulas in it that can essentially create any shape bellows, patrons will get access to that. Everybody watching this video will get access to the STL if you wanted to print one of these. I'm not sure how entirely useful that would be because since I'm not even sure what piece of equipment this goes to, but I always release whatever we work on in the channel as an STL for folks to download and print if they want to. And if this is by chance your first time here on the channel, this is all we do. It's all functional prints like this and the design and engineering and other tools and processes and such to go along with it. So if you like that sort of thing, check out some of the other videos on the channel. And if you like what you see, hit that subscribe button. And guys, if you do, I'll see you next Friday.